Hello guys, my name is Dan and welcome to my channel. This is my first video here. So I am currently learning reverse engineering and I thought might as well teach you guys as well. So there's this problem called heap 1 from Protostar, which I actually found on the live overflow channel, when I was watching a video, which will be linked down in the description. Great video. However, I felt like the video skipped over some details which I actually couldn't solve this myself without researching a bit more in depth. So I thought, why not show you guys how I did it and how it actually works more in depth than that video. So let's look at the goal of this problem. Here we have a main function and a winner function, and the goal is to execute the winner function, which is not called anywhere in main. And to do this, we are going to use our good old friend heap overflow. How are we going to do it? Let's have a look. So the way heap overflow actually works is very similar to a stack overflow. It's just another buffer overflow attack, and it functions a bit different because of how memory is allocated on the heap. So to allocate memory in the heap, we usually use malloc. So malloc is a function which reserves a provided number of bytes, let's say 4. 4 bytes on the heap. So it will provide us with a pointer pointing to the first address. Let's say this is the first address. And this is all reserved memory. This is all reserved. Pardon my drawing. I know it's terrible. And we can write to this memory freely. Now, because of how C and C++ works, when we use strcpy, which is a very infamous function, which you should not use, it basically does not check the size of the thing that it's copying and whether it's allowed to copy the object of that size into the allocated memory. So if we provide this pointer right here, let's call it B. So this is the pointer. If we provide that as a destination to strcpy, but we provide the source, let's say the source is pointing to a string which says hello world. So this is the string, and this, let's say there's a source pointer that points to this. And we call strcpy with these arguments, with this as the destination and this as a source. It's not going to check whether hello world is 4 bytes long, which it obviously is not. It's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and a null terminator, so 12 bytes long. And it's going to copy all of that in here. And it's going to start from here, and it's just going to go straight over and write over all of this data here. So how can we use this in our problem? Well, let's go ahead and take a look. So the first thing we want to do is put the source code in a source.c file. Here we have a struct internet, which has a char pointer name, which is actually just a string in C. And we have the winner function, which prints this. Then we have the main function, in which what really concerns us is these malloc functions. So we allocate memory for the two internet structs and for their names. And what we're actually interested in is these names because of these two string copies here. So we see that we need two command line arguments, and they're copied in the name pointer in each of these structs. So let's take a deeper look into how this program runs. So let's first of all, we have to compile it, and we have to compile it with these specific compiler flags. So fno stack protector and fno pi, which will enable us to actually exploit it without going into too much detail. Why? It's actually what prevented me from exploiting it when I was following the video, because I did not have the compiled binary. So now that we have compiled it, we're going to run it. So let's first run it without any arguments. So we got a segmentation fault, which is expected. But let's go ahead and run it through a debugger. So just say run. And we have a segmentation fault, and we can actually see that why it's happening is because the source is 0. So we haven't provided any arguments to it. So now let's provide argument 1 and argument 2. So we provide two arguments, and we see that the program executes properly, and we get the print message from the end, and that's correct. So in order to analyze it more in depth, we are going to disassemble the main function, and we can see all of our four of our malloc calls, and then we have the string copy calls. So we're going to put a breakpoint after the second string copy call. So this is here. So breakpoint at main and plus 165, and we're going to run it again using the same arguments. So we can see now we have hit the breakpoint. So what we want to do now is actually search the heap for our arguments. So search for the first argument, and we can see that it's located on the heap on this address. This is because we used malloc, if you remember correctly from before. We used malloc to allocate memory on the heap for this argument, and now we have used string copy to copy it there. So now this memory contains our first argument. And we need to do the same for the second argument. So we're going to search for that. And this is the memory location containing the second argument. Now, what our goal is with this exploit is, let me go ahead and open source code again. So we want to use the first argument in order to overwrite this pointer in order to point to the winner function. And how are we going to do this? Well, if we look at our, let's go ahead and disassemble main again. So we have this puts call here. So this is what we are targeting. We want to make the program point to the winner function instead of the puts function. So this call here, this call is still going to happen, but we are going to look at the global offset table, and we're going to get the address of the winner and replace the puts function in the global offset table. In order to do that, we need to find the difference in addresses between the first and the second name pointer. So we have searched, so we have the addresses for both of these arguments, and now we are going to print out the memory contents from the address of the first argument, and we can see this is where the actual pointer for the second name is located in the heap. So this address, this is 4 bytes, and this is 4 bytes. So this starts at 405 to E8. And the difference between 405 to E8 and 405 to C0 hexadecimal is actually 40 in decimal. And now what we need to do is find the addresses of the win function. So we are going to use this object dump -d exploit, and we're going to grep win, and this is what we get. And we need to find the address of the puts function exploit, and we grep with puts, and this is the address of the puts function in the global offset table. So the D basically stands for disassemble all, and this R is for dynamic relocations. And since puts is in the glibc, we need to search for it as a dynamic relocation. And now what we need to do with these is we need to go back into point debug, exploit, and we're going to run. However, now we're going to run with basically /bin/echo -ne. We're going to paste in 40 zeros. And then we have to enter the address of the puts function. And we forgot this here, the quotation, and the back quotes, and then let's say a here. So What we can see now is that we get a segmentation fault again. But what happened now is if we look at the RIP, which is the instruction pointer register, we have 61616161, which is actually just our AAAA, which is great. So we got hold of the instruction pointer, which means we successfully executed our exploit. And now all we need to do is replace this with, again, we're going to do /bin/echo -ne. And now we just need to put the winner address in there. So it's, again, going to be backwards. So 66, 11, 40, and 00. And we have a winner. And that's basically all. So it enabled us to execute it. Another way you can do it is you can use Python 3. So in order to do it, we are just going to do the same thing as before. So basically just run the exploit. And we're going to use backquotes in order to use the Python script to print out the outputs. And we basically have used heap overflow. And that's it for today. Thank you for watching. I know it wasn't great, but I hope you learned something new. All the useful articles and videos I used to research are going to be in the description below. So thank you all for watching and see you next time, hopefully with a better exploit. Thank you. Bye.